Welcome to cryptography session. Today, Diffie-Hellman key exchange topic will be discussed. Diffie-Hellman algorithm is one of the type of key exchange algorithm which is used to exchange session keys between two entities. So this algorithm was implemented by Diffie and Hellman at the year 1976, which is purely based upon public key concepts. That means that two entities can exchange secret key between them by exchanging their public keys with themselves. So it is mostly used for commercial purpose. And in this algorithm, the calculation is purely based upon two entities, private key and public key notations. And for the calculations, the exponentiation operation will be done. So this is the overview idea of algorithm. We should take a prime number q for this calculation. So q should be the largest prime number, and alpha is the primitive root of the prime number. So we already know that for calculation of primitive root, so if we take q is a prime number, then number of primitive roots calculation is pi of n. So in this way we can able to calculate. For example, I am taking the prime number as 7. So pi of 7, so which is equal to pi of 6. So pi of 6 is 2 into 3. That means totally 2 primitive roots are available in 7. So alpha should be those any number of 2. So alpha is a number which is less than q, and alpha should be the primitive root of q. In this way, Alice and Bob should select the same prime number and same primitive root for their own calculations. Let us take a private key XA for sender, XB for receiver. So those XA and XB values should be less than the prime number value Q. So after selecting private keys of those entities, they should calculate their own public key. So YA is the public key of sender. So that for calculation, the value is, or the formula is alpha to the power XA mod Q. Here alpha is the primitive root of the prime number Q. XA is the private key of user A. So in this method, YA is calculated. Like that, the public key YB value is YB is equal to alpha power XB mod Q. Here also alpha is the same primitive root of the given prime number Q. XB is the private key of user B. Then after calculation of public keys, they exchange their keys. So sender send his public key YA to the receiver B, and the receiver send his public key YB to the sender A. After exchanging their key, they will separately calculate the secret key. So if the sender calculates secret key, means it is termed as KA. So KA is calculated based upon receiver's public key with its own private key. So the formula is KA is equal to YB to the power XA mod Q. Like that, after receiving public key of user A, receiver B calculate his own secret key KB. So the formula is KB is equal to YA power XB mod Q. Then finally, these values, that is the calculation of secret key KA and KB should be equal. So we should verify that value. So how can we verify it? So that diagrammatic steps will be written as an algorithm way. So first we take the largest prime number Q. Alpha is the primitive root of Q. So at user A, two calculations are done. First we should take or choose the private key XA. So the XA value should be less than Q, and we calculate YA value. YA is equal to alpha power XA mod Q. Like that, B calculation is available. After exchanging YB and YA values to both entities, Ka and Kb are calculated. And we should prove Ka and Kb's are equal. So how can we prove it? Let us take Ka value. So in this algorithm, Ka is equal to Yb power Xa mod Q. So I am writing here. And what is the value of Yb? The formula is Yb is equal to alpha power Xb mod Q. So instead of Yb, I am substituting alpha power Xb. So the value will be rewritten as alpha power Xb whole power Xa mod Q. So if any power values are available, we can exchange that value. So a to the power m whole power n can be rewritten as a power n whole power m. So like that formula, I interchange the Xa and Xb in power formation. So that will be rewritten as alpha power Xa whole power Xb mod Q. So if you check alpha power Xa, so alpha power Xa is nothing but Ya. So instead of this value, I am substituting Ya here. So the value is rewritten as alpha power, that means Ya power Xb mod Q. So if you check Ya power Xb, the value is Kb. So therefore Ka and Kb's are equal. So this is the Diffie-Hellman algorithm. Let us take the problem. So here I am taking the largest prime number Q is equal to 353 and alpha is one of the primitive root of Q. So I am taking alpha is equal to 3 and they will give the private keys of both users. So Xc value is 97, Xp value is 233. The formula is Ya is equal to alpha power Xca mod Q. So here alpha is 3, Xca value 97, Q value 353. So here Q is the prime number, so we should implement Fermat's theorem for this exponentiation calculation. So the Ya value is 40 at last. The formula for Yb is equal to alpha power Xb mod Q. So after substituting the values, the answer for Yb is 248. So this value should be exchanged. That means Ya value should be exchanged to Bob, Yb value should be exchanged to Alice. After that, they will calculate Ka. So at user A, Ka is equal to Yb power Xa mod Q. So you substitute the value, the answer is 160. So it is calculated at sender A. And at receiver B, Kb is equal to Ya power Xb mod Q. So after substituting the value, the answer is also same. So in this way, we may able to implement a Diffie-Hellman algorithm. But there is a possibility of attack in this algorithm because after calculation of their own public keys, they will exchange the public keys with themselves. So at the exchange side, if Darth is an intruder, he will try to access the public keys of Ya and Yb means there may be the possibility of attack. So this type of attack is called as man in the middle attack. So after calculation of Ya, the value Ya will be transferred to receiver Bob, but instead of receiving to Bob, it will be hacked by the intruder Darth. And at receiver side, after calculation of Yb, Bob will try to send the public key information to the sender Alice, but instead of going to Alice, it will be hacked by the Darth Yb. So now the intruder Darth have the sender's public key Ya and receiver's public key Yb. Then Alice need Bob's key. Instead of that, the public key is sent from the Darth side, so it is named as YD2. So according to YD2, Alice calculated the secret key value K2. And at receiver side, instead of receiving Ya value, Bob will receive the value of Darth with the public key YD1. So he mistakenly calculated the secret key with the YD1 value. So this is K2 and K1. These are all wrong keywords of Alice and Bob. At intruder side, he generate two private keys XD1, XD2 and he calculated YD1, YD2. That value only transferred to both Alice and Bob. Now, this Darth has a public key Ya and a public key Yb. Using that Ya and Yb value, he calculated the secret key K2 and K1. So Alice and Dorothy have the secret key K2. Dorothy and Bob have the secret key K1. So if they exchange themselves, they identify that keys are same. But that keys are only generated by Dorothy because he tried to access YA and YB. So this type of attack is called man in the middle attack, which was done at Diffie-Hellman exchange algorithm. So this is the overview of that algorithm. So for avoiding man in the middle attack, we should transfer the public keys in an encrypted way. So either you transfer the public key with symmetric key encryption, or you put a signature and you may be able to transfer that secret key. So instead of transferring secret key plainly, we should encrypt that secret key with any one of the general cryptographic algorithm. So for using that type, we may able to avoid this man in the middle attack. Thank you.